We're going to go ahead and take a look at the trigonometric definitions of sine, cosine, tangent, and their three reciprocal functions. Now, it can be done looking at a circle. So we're starting off with a point, xy, so we're going to go ahead and draw ourselves a triangle going over x units, up y units. We have our point xy right here. We always make our triangle to the x-axis, never to the y, and then we can go ahead and use our hypotenuse, and which is the Pythagorean theorem, to get that hypotenuse. Now, sine can be defined as y over r, because if you think of SOHCAHTOA, it's the opposite, which is y over r, which is your hypotenuse. Cosine can be defined as x over r, because remember SOHCAHTOA, it's adjacent, which is x, over r, which is your hypotenuse. Or tangent being opposite, which is y, over adjacent, which is x. So it can be done with either SOHCAHTOA or this definition. And then, of course, we have the three reciprocal functions. We have our cosecant, which is a reciprocal sine, so you're flipping it upside down. Cotangent, which is the reciprocal of tangent. Or we have secant, which is the reciprocal of cosine. Also be aware that sine squared plus cosine squared equals 1, and 1 plus cotangent squared equals cosecant squared, or tangent squared plus 1 equals cosecant squared. We can go into more detail what those are and why in class. Now, let's go ahead and take a look at this one here. It can be done either with that definition, or it can be done with drawing a triangle and using SOHCAHTOA. So the first thing I would do is I would plot this point, go 8 units over, 15 units down, and then draw yourself a right triangle, always going to the x-axis. So it's 8 over, 15 down. Your angle comes out here in the pink. The angle you're looking at is always in the triangle at the origin. Well, we can just go ahead and use our Pythagorean theorem to be able to get that missing side. And we get 17. Now, technically speaking, when you take your square root, it's plus or minus. But according to our definition back here, that r is always the positive square root. So make sure that you're always making your hypotenuse r positive. Now, whether you use that definition or SOHCAHTOA, we can go ahead and work these out. Sine, opposite, over hypotenuse, or according to the definition, y over r. Cosine is adjacent over hypotenuse, or x over r. Tangent, opposite of negative 15 over adjacent of 8, or y over x. Then you also have the reciprocal function. So tangent, cotangent, you got to flip your tangent upside down. Secant, you got to flip your cosine upside down. Cosecant, you got to flip your sine upside down. Quadrantal angles are those angles whose measures end up being on one of the axes. So here, if you're going straight to the right, that would be 0. Or if you're right here, that would be going straight up. That's a 90-degree angle. If you go halfway around, that's a 180-degree angle. Or if you go all the way down to the bottom, that's 270. Or if you go all the way around, that's 360. Or you can keep going, because if you go all the way around and then go up, that's 360 plus another 90. So that would then be 450. Sorry. And you can also have the negative angles going backwards. So let's take a look at this one here. 180. 180 degrees is over here. At some point where the x-coordinate's negative, the y-coordinate's positive. Now, it doesn't work to form a triangle here because there's no triangle form. So SOHCAHTOA doesn't work. So we need to go back and use that definition. Now, we also need to figure out r. So we're going to, according to our definition, it says you got to take the x-coordinate square it plus the y-coordinate square it, and it has to be positive. So when we do that, we're going to take our x-coordinate, which is negative r, all squared, plus our y-coordinate, which is r squared. So we get the square root of r squared, which simplifies down to r. So when you do the sine of 180 degrees, that's going to be your y, which is 0, over your r, which is r. So 0 divided by anything is 0. Cosine is your x coordinate, negative r, over r, which is negative 1. Tangent is y over x. So you got to take your y value of 0 over your x value of negative r. 0 divided by anything is 0. And then you have the reciprocal function. So cotangent, you got to flip this one upside down. Puts 0 on the bottom. If you ever divide by 0, it's undefined, or the empty set. Cosecant, at the very bottom here, is the reciprocal sign. Also that when you flip that upside down, you get 0 on the bottom, which is undefined. Secant is the reciprocal of your cosine, and so we get negative 1. Now we're going to look at reference angles. Reference angles are basically how far you are from the x-axis. So if we look at 160 degrees, 160 is over here. When we're looking for the smallest angle between angle we have and the x-axis. Well, the x-axis over here is 180. How far are we away at 160? Well, that means our reference angle is 20. Your reference angles are always positive in something from the first quadrant. When you look at negative 110, here's negative 90 down here to the axis, so negative 110 would have to go a little bit beyond that. So we want to know how far are we from the 180 mark. So this is at a 110, we need to look at 180, well that's a 70-degree angle away. Once again, reference angles are always positive in something from the first quadrant. 275, well 270 puts you right at the bottom, so 275 puts you just past that. So we're at 275, and we got to get to the x-axis, which is at 360, because we always want the smaller one. So what's the difference between 360 and 275? And that would be 85 degrees. Over here, at negative 3 pi over 4, your reference angle is going to be pi over 4, because you're a fourth of a pi down from pi right here. If it's anything pi over 4, your reference angle is pi over 4. If it's anything pi over 3, your reference angle is pi over 3. If it's anything pi over 6, your reference angle is pi over 6. So those reference angles are going to come into play when we try to work these out. When we look at negative 60, it puts us here. How far are we from the x-axis? Well, that's 60 degrees. So really, all we have to look at it is the cosine of 60 degrees. Once again, that's one you're supposed to have memorized, and so we put down 1/2. We now have to decide if it's positive or negative. Cosine deals with x, and we're in the fourth quadrant. Any x in the fourth quadrant is positive, so we're going to have this as positive 1/2. We're going to look at our reference angle here. 5 pi over 4 puts you over here. 5 over 4 is 1 1/4. So it's 1 1/4 pi. So here's 1 pi to the axis, and you're a fourth of a pi beyond. So your reference angle is pi over 4. You're supposed to have memorized the cosine of pi over 4, which is the same as the cosine of 45, which is root 2 over 2. We now have to decide if it's positive or negative. You'll notice it is negative here, but let's understand why. Our angle's in the third quadrant. Cosine deals with x, which means you have to go to the left to be able to get to that, which means you're going in the negative direction. Then we'll look at negative 150. Well, positive 150 would put you up here into the second quadrant. So negative 150 is going to rotate that same distance but backwards, so it puts you down here in the third quadrant. How far are you from the x-axis? Well, you're 30 degrees away, so your reference angle is 30. So all we have to do then is go ahead and take a look at what we're supposed to have memorized, which would be the tangent. So we're going to look at the cotangent of 30, but we know that that's the reciprocal of the tangent of 30. Tangent of 30. Oh, we know that the tangent of 30 is root 3 over 3. But I'm dealing with cotangent, so I got to flip that upside down, because cotangent's the reciprocal of my tangent. Once again, we don't want to leave roots in the bottom, so you have to rationalize it by multiplying top and bottom by root 3 and simplifying it, so we get root 3. We now have to decide if it's positive or negative. You're going left and you're going down, and tangent deals with x and y. You're going left, so that's negative for your x. You're going down, so that's negative for your y. So if you're dividing two negatives, you're going to get a positive answer. Taking a look over here, anything pi over 3 has a reference angle of pi over 3. So we have that. Cosecant deals with sine. So we're supposed to have the sine of 3 pi, or not 3 pi, the sine of pi over 3 memorized, which is the sine of 60 degrees, which is root 3 over 2. But we got to flip that upside down, so we get 2 over root 3. Then we have to rationalize that, and so we get this. Now, you'll see the negative floating along here, but let's understand why it's negative. We're dealing with sine. When we graph this, this angle is in the third quadrant. Sine deals with y. We had to go down to get that, so your y is negative, so that means your answer is negative.